Hey students, this is Miss Wint, and this video is going to introduce you to the beginning of Chapter 2. So it says Chapter 2.1, so that means the first section, and it's all about motion. Okay, so something to think about. Are you in motion right now? So as you're sitting watching this video, are you moving? Is your body going to a new location? The answer is probably not. If you sit and close your eyes, does it feel like you're moving from one place to another, or is your body just staying in one place? And if you look at your neighbor or maybe like a piece of furniture in your house, does it look like that neighbor or piece of furniture is moving? Okay, so those are all kind of indications, what you feel and what you see with your eyes tells you if you're moving. However, you got to remember here, you're on planet Earth. The Earth is rotating, so it's spinning around in a circle, and it's going around the sun, which is revolution. And plate tectonics you learned about in 8th grade, those guys are moving. So really, you are in motion right now. It probably just doesn't look or feel like it because everything around you is moving in the exact same way. So you don't notice that your body is moving. Okay? But you are, in fact, moving. However, that's a pretty complicated way of looking at stuff. So we're going to simplify it. Okay? So here's our definition of motion. Motion is when an object, and you could be the object, is changing its position from a reference point. Okay, now don't worry about writing this down for distance learning, okay? But we should know what a reference point is. It says a reference point is something you use to compare to an object to see if it's moving. So the most common reference point you use is probably the ground, or maybe a tree that's touching the ground, or a building touching the ground. Okay, so for example, your body is probably in a chair or maybe laying on the bed if you're doing distance learning, and you are not moving compared to that chair. You and the chair are together, you're staying together, you're not getting closer or farther apart from the chair. So you would say you're not moving compared to the chair would be your reference point, something you're comparing your body to. Are you getting closer or farther away from the reference point? However, if we use the sun as a reference point, because you're on the earth spinning around, if you look at the sun, it appears that the sun is moving, either closer to you or farther away from you, depending on if it's setting or rising. So if you compare your body to the sun, it does seem as if something is moving. Now, you might think the sun is moving, but really it's you that's doing the moving. All right? So a reference point is something you compare to see if something is moving. And you see, is that thing getting closer or farther apart from the reference point, or are they staying in the same place? All right, so you're going to see on your worksheet that motion is a vocab word and reference point is a vocab word. All right? Now, we have another word for motion, and that is speed. Okay? And speed would be how fast are you moving or how slow are you moving? Okay? Now, the math definition for speed is how far an object travels divided by, right? So that's a math function, divided by the time it takes to move. In math problems in your math class, they might call it rate. So what's the rate of the car or the rate of something? Okay, and there's a lot of ways to measure this. Okay, so how far, that's a distance. And we could measure the distance of a car traveling in miles. Maybe if we measure a race at a track meet, we use meters. If we're measuring how far a bug is moving, maybe centimeters, kilometers, inches. Those are all different ways to tell a distance. And if we have to divide it by time, time could be in hours, seconds, years, days, weeks, whatever. So It's some kind of distance divided by some kind of time. And there's lots of examples depending on what you're measuring in. Okay, so it's always very important when we do math problems with speed, we always have a label, because centimeters per year, that's a pretty small, slow distance compared to kilometers per second. So it's really important that we label stuff. Okay, now you're going to read about another word that's very similar to speed called velocity. And this is the speed of something, but we're just going to add a direction to it. Okay, so instead of just saying like miles per hour, we might say miles per hour going left or kilometers per hour north. So we're going to add a direction, maybe a compass direction like north, south, east, west, maybe left or right. We might say up or forward or backwards. Those are all different direction words. So velocity is a little more specific than speed. And if you're doing a problem with velocity, make sure you have a direction as part of your units. But the math is the same. It's still a distance divided by a time. We just add a direction to it. All right, so there's some graphing in this chapter. Let's take a look a little bit with the graphing, okay? So every math problem we do, we can also do a graph. So speed, the formula is distance divided by time. So let's say this green car went 100 miles for his distance, and it took him 4 hours to do it in. We'd take 100 miles divided by 4 hours, and his speed would be 25 miles per hour. Okay, so that's pretty simple, and we can use calculators all the time to do the math. That's not a problem. But let's say I want to make a picture of this. All right, so here we actually have two cars. Here's our green guy, and then we have another car, a black car. And I want to figure out, is this black car going faster or slower than the green car? All right, so check this out. This black car went 400 miles in 5 hours. And I have a black dot here to match the black car. So I put the black dot at 400 miles in 5 hours. All right. So that is his speed, that dot. But a graph isn't really a dot. We want a line. But I know that this car, after 0 hours, he also went 0 miles, right? Because he hadn't started yet. So I can use this point here, the origin, at 0, 0, and I can make a line. And it didn't quite connect, but just pretend it connected all the way to 0, 0, okay? So this line here is the slope here that you do in algebra class. I can see how steep this line is. I'm going to make the same thing for this green car. So he went 100 miles in 4 hours. So there's 100 miles in 4 hours. So I put a dot there. And I'm going to draw a line through the origin as well. And I can compare these two lines. And something I love to do, and I'm not sure it's going to let me do it with this presentation the way it is here, is think of the lines as a slide. So if I was at a park and I sat down at this black dot and slid down, this would be a pretty fast slide. And this black car is going at pretty fast speed. Now compared, if I sit on this green dot, that's a pretty slow slide. So out of these two cars, I can tell by the graph that because this slide is steeper or more vertical, more up, the black car is going faster than the green car. Now the graph I can also figure out for different parts of the trip how far they went or how long it took. So I could pick like this spot on the graph and I can say, oh, the green car, after 2 hours, he went about 50 miles. I could say if he keeps going, if he drove for 10 hours, that would be about 250 miles. Okay, this black car here, after 2 hours, he went like 175 miles or so. I could pick any spot on the graph. So 3 hours, go straight up. About 250 miles in 3 hours for the black car. The green car, 3 hours would be only about 100 miles. Not even. Maybe like 75, right? All right, so think of the lines as slides. The steeper the line, or your algebra teacher would say the bigger the slope, the faster your car is going to go. All right, so this simulation that I used to do is now broken. So instead, I'm going to take you to a website called explorelearning.com. You will be on this website later. And it uses, they're called gizmos, and they're little simulations. So here I got a guy here in red, and I'm going to add a blue guy too. My son just joined us, even though we're making a video.
Yay!
And if I have them both starting in the same place but racing, if I make the lines like this, which runner is going to be faster? The red one or the blue one? What do you think, Matthew?
But what is it?
Okay, I'm going to hit play with my stopwatch here. And the red runner is faster, and he made it a lot farther too in the same amount of time. So the graph here, because the red line is steeper, that shows that the red guy should be faster than the blue one. All right, now check this out. What's going to happen when it reaches 1 minute? Okay, so they're both running. And then what happens here at these flat parts? Watch what happens. Well, they're just standing there. All right, and then when the blue guy, they both finished together in the same spot, and they both started in the same spot, but they were resting in the middle. The red guy rested longer. The blue guy rested for 2 seconds, and then he finished the race. So let's watch it again here. So you can see when they get to the flat part of the graph, they stop.
Yeah.
Okay. Yeah. Now, what would happen in this situation? Will they start and end in the same place? Let's find out. They both rest. Okay, so if I get rid of the blue guy, just watch the red guy. So he goes forward, he rests, and then when the line went down, he actually went backwards to where he came from. Okay, so if you think like a number line in math class, when you go backwards on a number line, you get those are like negative numbers. Those are negative numbers. Okay, so you're going to get a chance to play with this later on. It's kind of a cool little activity, but it helps you be able to visualize just the different graphs that are made by different motions. If you're going forward or backwards, fast or slow, and what that graph is going to look like. All right, so let's look at a couple of these guys here. All right, so if I have these two runners, it says which line is steeper, the boy or the girl, and why? Well, it looks like the red line here for the boy is a steeper line. Like if this was a slide in the park, that would be a really fast slide. So the boy ran faster than the girl. They both started at the same place at the school. They both ended at the tree. It's just the girl took more time to get there. The boy got to the tree after 10 seconds. So you see, if this is 20, then halfway there would be 10. But the girl took all the way to 100 seconds to do that same distance. So the girl was slower. Okay. How about this one? where is the runner going to have the fastest speed? So part A, part B, or part C?
C.
Why C, Matthew?
Because it's steeper.
All right, so
If you choose B, then you're totally wrong. Because you stop right there. And A is not steeper than C, so A is going to go a lot slower.
you are absolutely correct. Good job. All right. So, whoops. So in this picture, C would be the fastest. A is kind of a medium speed, and B here, like we
Stop.
said, is going to be stopped at this flat line.
At a horizontal line.
Yep, at a horizontal line. Very good. Okay.
What did you notice
So-
about the graph when the runner stopped? When the runner is stopped, the line is horizontal or it has a slope of 0.
Yep. So this is a zero slope in algebra class. It means zero speed in physical science. Same thing. All right.
Take that and put
And
it
then we already
straight
talked about we had a faster speed at the end. All right. So, a couple things to remember, guys. Slope of a line indicates speed. So if you can use your algebra skills to find the slope, then you know exactly what the speed is. But you could just compare things and say that one is faster or slower than another. A steeper slope is going to be a greater speed. And a slope of 0 or a flat horizontal line indicates no movement. All right, so we're not going to be able to play the game as part of distance learning, but I wanted to show you the stories real quick, okay? So in this story, it says we're walking away very slowly for 4 seconds. So here's a really flat line here for 1, 2, 3, 4 seconds. Then we walk very quickly the next 4 seconds. So now we have a steeper slope for 1, 2, 3, 4 seconds. We stand still for 2 seconds. That's the flat part. And then we walk moderate or medium speed the last 2 seconds. Okay, so there is, you can make stories to go with graphs, and you'll have some assignments or some pictures that you'll have to kind of describe what's happening. So in this picture, we're going fast for 8 seconds, and then the slope gets flatter, so we go slower at the end.
It goes up.
Okay, so this one here, we go
3 seconds.
pretty fast for 1, 2 seconds, and then we stand still 1, 2, 3, 4, 5 seconds, and then we go at a medium speed 1, 2, 3, 4,
6.
5 seconds.
6 seconds.
Nope, you got to count the spaces, not the dots. So there's 1, 2, 3, 4, 5.
So
All right, so that is, we're going to kind of stop there, guys, with this video. Now, if you go back to Schoology, the directions are going to tell you that you need to read, look over the first part in the textbook, and you have a worksheet here called Chapter 2.1 Reading Worksheet. So take a look at that guy, see how it goes, and once you get that done, try your hand on some math problems, okay? Have a great day, guys.